Example 2, y double prime minus 3y prime plus 2y equals negative 3 e to the negative x minus 10 times cosine of 3x with the initial conditions y at 0 equals 1, y prime at 0 equals 2. So this is the initial value problem. Step 1, find yc, or the complementary solution, by using the associated homogeneous equation. As y double prime minus 3y prime plus 2y equals 0 with the auxiliary equation in the form of m squared minus 3m plus 2 equals 0. Factor completely to get m minus 2m minus 1 equals 0 to get m equals 2 or m equals 1. Then we get the solution y1 as e to the 2x, solution y2 as e to the x, then the complementary solution, or yc, in the form of the linear combination of y1 and y2 as c1 e to the 2x plus c2 e to the x. Next, step 2, we find yp, or the particular solution. Consider the gx in the form of negative 3 e to the negative x minus 10 times cosine of 3x. From the solution y1 and y2, we have the exponential e to the negative x, but e to the negative x is not the same form as e to the 2x, or also not equal to or not the same form of as e to the x. So then the solution for the exponential form not repeated. Also no cosine or sine term as part of the complementary solution. So therefore, this is case number 1. Next, we're gonna put together to find the form of the solution yp. From exponential e to the negative x, have e to the negative x with the coefficient a. For the cosine term, we're gonna have the combination of the cosine 3x and the sine of the 3x with the coefficient b and c. So we are going to find the values for a, b, and c. Since yp is the solution, it must satisfy the same differential equation, or the non-homogeneous differential equation, which yp double prime minus 3 yp prime plus 2 yp equals negative 3 e to the negative x minus 10 times cosine of 3x. Then we're gonna need yp prime and yp double prime. Yp prime is negative a e to the negative x minus 3 times b times sine of 3x plus 3 times c times cosine of 3x. Yp double prime is positive a e to the negative x minus 9 times b times cosine of 3x minus 9 times c times sine of 3x. And then replace yp prime, yp double prime into the differential equation. We have a e to the negative x minus 9 times b times cosine of 3x minus 9 times c times sine of 3x minus 3 times yp prime, or negative a e to the negative x minus 3 times b sine of 3x plus 3 times c cosine of 3x plus 2 times the yp, or a e to the negative x plus b times cosine of 3x plus c times sine of 3x equals the right hand side, which is negative 3 e to the negative x minus 10 times cosine of 3x. And next we are going to collect the coefficient of the same factor, the same term on the left side and the right side of the equation. So we have the term for e to the negative x, cosine of 3x and sine of 3x. For the e to the negative x, we have a plus 3a plus 2a equals negative 3, or 6a equals negative 3 to give us a equals negative 1 over 2. Next one, we're gonna look at the coefficient of the cosine of the 3x both left and right side of the equation. So to cosine of 3x, first one we have negative 9b minus 9c plus 2b to get negative 7b minus 9c equals the right hand side, which is negative 10. Next one, look at the coefficient of the sine of the 3x, the left and the right side of the equation. Starting with negative 9c plus 9b plus 2c. Then give us 9b minus 7c equals the right hand side, no cosine term. So we can see this as 0 multiplied by sine of 3x. So the right hand side coefficient would be 0. So from these two equations, we are going to solve for B and C. So multiply the first one by 9, multiply the second one by 7 to get negative so negative 63b minus 81c equals negative 90. And then the second equation is 63b minus 49c equals 0. Add them together. Then we get negative 130c equals negative 90, or c equals 9 over 13. And then solve for b. So we get b equals 7 over 13. Now we get a, b, and c. Next, we put them together as a solution yp. So yp equals a, which is negative 1/2, e to the negative x plus 7 over 13 times cosine of 3x plus 9 over 13 times sine of 3x as a particular solution. Then the general solution of this equation or this differential equation would be y equals yc plus yp, or c1 e to the 2x plus c2 e to the x minus 1/2 e to the negative x plus 7 over 13 cosine of 3x plus 9 over 13 times sine of 3x. Since we have two initial conditions, the first one, y at 0 equals 1 and y prime at 0 equals 2. So we're going to have to use these two initial conditions to find C1 and C2. Since y1 is known, now we're going to set aside y prime. Y prime would be 2c1 e to the 2x plus c2 e to the x plus 1 over 2 e to the negative x minus 21 over 13 of sine of 3x plus 27 over 13 cosine of 3x, and then use each initial condition. For the first one, y is 0 equals 1 equals c1 plus c2 minus 1 over 2 plus 7 over 13. And for y prime at 0 equals y prime at 0 equals 2. The expression would be 2 times c1 plus c2 plus 1 over 2 plus 27 over 13. And then we are going to find c1 and c2. So subtract these two equations to get negative 1 equals negative c1 minus 1 and 7 over 13 minus 27 over 13 becomes negative 20 over 13. Therefore, we get C1 as negative 20 over 13. Next, we are going to find C2. From C1 equals negative 20 over 13, so use the first equation. C2 equals 1 minus C1 plus 1 half minus 7 over 13, or 3 over 2 plus 20 over 13 minus 7 over 13, or 3 over 2 plus 13 over 13, which is 1. It becomes 5 over 2. So the solution of this initial value problem would be y equals negative 20 over 13 e to the 2x plus 5 over 2 e to the x minus 1 over 2 e to the negative x plus 7 over 13 cosine of 3x plus 9 over 13 times sine of 3x.